You know the biggest limitation of pretty much all our technology, right? The battery? Well, what if that was all about to change? Today, we're going to dive into a really cool breakthrough in material science that's aiming to create a super material, one literally designed to power our future. Let's get into it.
Oh man, we have all been there. You see that dreaded low battery warning and your heart just sinks. It really feels like no matter how slick our gadgets get, their power source is always playing catch up, always the bottleneck. And this leads to a massive question that scientists are racing to answer. Can we actually do better? Can we invent totally new materials that store energy way more effectively? So that quest for a better battery, it leads us straight into what's known as the energy storage challenge. And trust me, it's one of the biggest hurdles in modern engineering. The solution here isn't going to be found in some clever new software or a slick design. It's in the fundamental physical materials we build everything with. I mean, just think about it for a second. From the phone in your pocket to electric cars to the entire power grid itself, everything, and I mean everything, relies on storing energy and then releasing it when we need it. The problem is our hunger for power is growing way, way faster than the ability of our current materials to keep up. We've kind of hit a wall. We need something new, something much better. So in the ring for energy storage materials, you've basically got two main contenders, polymers and ceramics. Let's think of them as two different kinds of athletes, right? Each one has a really unique set of skills, but they also have some serious weaknesses. So on one side, you've got your polymers. These are fantastic because they're flexible, they're pretty easy to make. But here's their big downside. They're not great at storing energy. On the other side of the ring, we have ceramics. Now these guys are the powerhouses. They can store a huge amount of energy, and they have a super high breakdown strength, which means they can handle intense electric fields without failing. The catch? Well, they're brittle, they can crack, and they are notoriously difficult to work with. So it's a classic trade-off, you see?
So, the big question, the holy grail really, is what if you didn't have to choose? The ultimate goal of this research is to create a brand new material that takes the absolute best from both worlds. You get the awesome flexibility of polymers and the incredible energy storage of ceramics, all rolled into one. And that is where the hero of our story comes in, a hybrid material called a nanocomposite. This is the attempt to build that perfect, best of both worlds material, right from the ground up. The idea here is actually pretty simple, but it's incredibly powerful. It's kind of like adding steel rebar to concrete. You know, by itself, concrete is really strong, but it's brittle. And steel is flexible, but when you put them together, you get reinforced concrete, a material that is way, way better than either one is by itself. In this case, researchers are doing the same thing by mixing tiny ceramic particles inside a flexible polymer. But of course, there's a catch. You can't just throw them in a bucket and mix them together. It doesn't really work that well because the two materials don't naturally get along. And this is where the real genius, the actual breakthrough from this research, comes into play. They figured out the secret ingredient, a special coating for those little ceramic particles. Okay, so how did they actually pull this off? It's kind of like a recipe. First, they take those tiny ceramic nanoparticles and they give them a nice even coat of a special polymer called PVP. Next up, they dissolve the main polymer, that's the one that's going to form the flexible body of the material, into a solution. Then they mix the freshly coated particles in and they make sure they spread out nice and evenly. And finally, they just dry the whole mixture out, and what's left is a totally new, unified, flexible film. So what is this secret sauce, this PVP? Well, you can think of it like a chemical diplomat. Its job is to go in there and create a better, friendlier connection between the ceramic particles and the polymer that they're living in. It basically helps them bond and work together as one cohesive team instead of just being a clumpy, inefficient mess. Okay, so the theory is great, the process is clever, but did it actually work? This is where we get to look at the evidence, and honestly, it's pretty darn compelling. Right here, we can literally see the difference with our own eyes. These are images from under a microscope. Now on the left, that's the version without that special PVP coating. See how all the little ceramic particles are clumped together? That is really, really bad for performance. But now, look at the right. With the coating, wow, the particles are just beautifully, evenly spread out. That perfect, uniform structure is the key to unlocking this material's true power. And that beautiful new structure, it translates directly into way better performance. Let's just look at the numbers. The recoverable energy, that's the amount of power you can actually get back out of the material, it jumps by nearly 50%.
And the efficiency? It leaps from kinda so-so, under 50%, to almost 60%. In the world of material science, believe me, that is a huge improvement. This graph gives us another really cool way to see that success. Just think of the total area inside these loops as the stored energy. The red loop, that's our new material with the PVP coating. And look at that much larger shaded area labeled WREC. That stands for recoverable energy, and it's showing us, plain as day, that this new material can store and then release way more useful power than the original. So, to put it simply, the new material achieved an energy efficiency of nearly 60%. That number represents a major, major step forward in creating one of these composite materials that truly actually combines the best of both worlds. So, this is all fantastic work in a lab, but what does it mean for the real world? Why does this fundamental research actually matter to you and me? Well, the potential applications are absolutely huge. Imagine electric vehicles that charge in just a few minutes, not hours. Think about smaller, more powerful batteries for our phones and laptops that could last for days. We could see amazing breakthroughs in medical devices or even build more stable and efficient power grids for our cities. This is the kind of foundational science that makes all of that cool future tech possible. And all this leaves us with a final, really exciting question. We're always focused on the limitations of our current batteries, but what happens when those limitations start to fade away? What new technologies, what incredible new possibilities will we unlock when our devices can hold vastly more power and recharge in the blink of an eye? That's the future this kind of research is busy building for us.